We're finally all done with our integration techniques, and now comes the last part of this chapter, which is going to be integration by substitution. Now this is going to be exactly the same as U sub, okay? There's no difference over there. And the other thing that's going to be is that except of using U sub, you will be given the substitution, and I'll show you guys what I mean by that. Now, there are these two tips that I want you guys to remember when you're doing problems like these. And the first tip is that these are not integration problems, okay? So these are trig identity problems. So you need to be good at trig identities and turning one thing in trigonometry to a different thing, like you probably do in your trigonometry chapter. Apart from that, these problems will be algebraic problems. You will need to manipulate algebraic expressions and turn them into different forms, and so they will be algebraic problems. Other than that, you do not want to plan out these questions. When you see this question, you do not want to plan it out. You do not want to have it all figured out in your head. You do not want a strategy. Instead, you want to do these integration by substitution problems one step at a time. Think about just one thing, do that, the next step will come to you, and that's how you're going to be able to solve these. If you try and plan these out, you're actually going to get stuck and you're going to feel really bad. So let's get into the first problem, and I'll show you how to do these. Now, they've given us an integral over here, right? So this right here is an integral, and they want you to turn this thing into this thing. Actually, they know this thing is equal to this thing. All they want you to do is they want you to show them that this is actually true, and show them using this substitution. So they've told you that x is equal to sine squared theta. Now, using this, you have to show that this thing is this thing, okay? So that's what I'm going to do. Okay, so I already know that x is equal to sine squared theta. All I'm going to do is I'm going to write that integral, which is integral square root x over 1 minus x dx. So what am I trying to do? Remember, what did you do in U sub? You're trying to get rid of all the x terms. That's exactly what I'm going to be doing over here. So I remove those x terms, and I basically write sine squared theta over there. So that's a sine squared theta, that's a sine squared theta. Now this dx over here, clearly this dx does not belong over here, because you can see now we have terms that include the theta. So we need this dx to become d theta. And how did we do that in our U sub problems? Well, we have this thing, right? And it's basically an equation for x in terms of theta. They've told us that x is equal to sine squared theta. Now remember, we want a d theta over here, right? So if we have a dx in terms of d theta, right? If we have a dx in terms of d theta, we can basically substitute that and remove this dx. And how do we do that? Well, we have the equation for x. We know we can differentiate that. So we can differentiate that with respect to theta. And that is basically going to give us, so this is going to be 2 sine theta cosine theta. Now, I'm not going to be teaching you guys differentiation, so I hope you know how to differentiate things. So it's this thing right over here, remember? And we're still not done. We are trying to remove that dx, remember? So we need that dx as our subject, and if we move d theta over here, it's basically going to be this thing. Now we know what dx is equal to, so we can just go ahead and put this thing over here, and that's what I'm going to do. So this is going to be 2 sine theta cosine theta d theta. Now you can see I haven't planned out this question, and I'm not looking at, oh my god, my integral looks like that and my integral doesn't look like that. Oh my god, I can't solve the problem. That's exactly what you don't want to do. Want to do one step at a time. Everything is going to solve out itself. So far, you would be stuck on this problem. At this stage, you would be stuck. You would hit a roadblock. You'd be like, okay, I don't know what to do right now. And that's totally fine. Think about what you can do, okay? So I can't do anything useful over here. I can't do anything useful over here. But there is one useful thing that I can do over here, and that is if I basically realize if I basically realize that this thing is basically a form of the Pythagorean identity. And the Pythagorean identity is basically sine squared theta plus cosine squared theta equals 1. If you rearrange this, you'll realize that 1 minus sine squared theta is actually equal to cosine squared theta. Now see, this is clearly a trigonometry problem. Realizing this thing is an identity is a trigonometry problem. So you have to be on your A game in trig, and you have to be on your A game for algebraic manipulations. We're not integrating right now, okay? This is simple trig. So I remove this thing, okay, doing one step at a time. I just saw that that was an identity, so I'm going to remove that, put that over there. Now I can actually go ahead and take the square root, because both of these terms have a square. The sine squared theta and the cosine squared theta, they both have a square, so I'm just going to take the square root, remove those squares, and now I basically have this thing. What you can do now is realize that this cosine can cancel out with that cosine, so that goes away. You're left with sine theta multiplied by 2 sine theta, and this is going to become 2 sine squared theta d theta, and you have that thing right over there. Now if you tried to plan this out, you would have been cooked. So you'd never want to plan this out. Now let's go over to the next example, and over here we have this other integral, this thing right over here, and we have to show that it's equal to this thing right over here using the substitution u is equal to square root of x. Okay, so that seems fine. I'm just going to put that integral over here. Okay, and wherever I see an x, I'm going to try and put a u over there, okay? So I have an x over here, so that means, do I put a u over there? And that is going to be wrong. If you think about putting a u over here at this instead of this x, you would be wrong. That is because u is equal to square root of x, or square root of x is equal to u. You don't know what x is equal to, right? So how you cannot just replace a u for x. You cannot just put a u over here. So how do you find out what x is equal to? Well, you rearrange this equation and you basically get x is equal to u squared. So that's what I got to put in place of the x. So there was an x over there. I'm going to put a u squared over there. And then I'm going to have my 4 minus, I have a square root x. Right? In the integral, you can see you have a square root x. So what do I put in place of that square root x? I'm going to put a u, because I know the square root x is equal to a u. So that's what I'm going to do. And this is going to be a u over here. And now I'm going to have my dx. Now that dx does not belong over here. I'm trying to remove that dx. I'm trying to get a du. So I'm trying to get dx in terms of du so that I can substitute. And remember, I have this thing, right? So what I can do is I can basically differentiate dx with respect to du, and that would basically give me 2u. Okay, now I make dx the subject, and so this is going to be this thing, and I'm going to input that in place of the dx. So this is equal to 2u du, and this u cancels out with that thing, and then this 2 is going to multiply over here, and I am going to be left with this thing. And now this thing is still not that thing, because you can see it has those 2, 1, and over here we got this 4 and 1. So what do we do about these limits? What do we do about the upper bounds and the lower bounds? Well, you have to realize now the integral that we're talking about, this integral, this is not an integral in terms of x. This is an integral in terms of u. So we cannot use those upper and lower limits because those were for the x. So now we need to find the upper and lower limits for the u. So how do we do that? Well, we know that u is equal to square root x, or you can use this one where, you know, that u squared is equal to x. You can use either one, okay? And what we're trying to do is we're trying to find what is u when x is 4 and 1, okay? And so that is going to give us our upper and lower limits for the u. So that's what we're trying to do. So we're going to first find the upper limit. That's going to be square root 4. That's going to be 2. That's the upper limit. You erase the upper limit in the integral, put a u over there, and then for the lower limit, that's going to be a 1. That's going to be a 1. So you're gonna the one is already there, so you don't have to do anything over there. And now this thing over here is actually that thing up there. Now you have that integral. Moving on, we got this other example, and we're supposed to turn this thing into that thing, and we're given that u is equal to square root 6 minus x, okay? So I've got this thing over here, which is 5, 2, I got a 5 over there. I got an x over here, but I'm trying to remove that x. So I know that my u is equal to 6 minus x, and I'm trying to replace an x. So I need to know what the x is equal to so that I can replace the x. So I can rearrange this a bit. I can rearrange this a bit to find out what the x is equal to. So you throw the square root sign over there. This becomes u squared is equal to 6 minus x. And then you rearrange this a little bit more, so it becomes 6 minus u squared. Okay, now that is what the x is equal to, so I just put a 6 minus u squared over here, and then I have this plus symbol, and I know that square root 6 minus x, I know that square root 6 minus x, this thing is actually equal to u, okay? And that's been given to me in the problem. So this is going to be a u, and then there's going to be this dx that I don't want. So what do I do about that dx? So I know that this is what x is equal to, so I can differentiate it, and this is going to be negative 2u, okay? And then you send the du over there onto the other side, and so this is what you get. And you can actually go ahead, put that thing in here. That is going to be negative 2u du. Throw that thing in here, can basically throw that thing in here, and that is going to be negative 10 u du. Okay, so I've tried out my best over here, and my integral still doesn't look exactly like that. And what about my limits? Can I change my limits? I think I can change my limits, so that's what I'm going to go for. So what is my upper limit? Well, my upper limit is going to be, I know my x is equal to 5, so this is going to be 5 over there. And let's find out what this is equal to. So it's going to be 6 minus 5, I know that's going to be 1. 6 minus 5, I know that's going to be 1. And square root 1 is equal to 1. And then I am going to have my lower limit, which is equal to, and that is going to be equal to, actually this right over here is, this is 2, and so this is going to be 4, and this right here is 2. So that right there is my upper limit, and that right there is my lower limit. Okay, and so I can go ahead, I can put those in. So my upper limit is 1, and my lower limit is 2. Okay, now my integral is still not, that thing. So how do I turn it into that thing? Well, if you look at that, that seems like a factored form of a quadratic equation, right? Because that's how a factored form of quadratic equations look. There's basically two brackets and they have u terms, and that's exactly what I have over here. I have a quadratic equation. I can factor it and make it into that form. I already have the 10u over there. I'll also have the 10u over there. I have the limits. My limits are correct. One of them is 1 and one of them is 2, but the thing is my limits are swapped. So I have 1 on the upper limit side, I have 2 on the lower limit side. I know I can fix that. So what I can do is I can basically take this negative side, I can write this negative sign as negative 1 multiplied by 10u. I take that negative 1 outside of the integral. Okay, and now there's basically this integral property which you may have studied in your AS, and that basically says that if you have this thing, if you have a, b, something in here, f of x dx, then that basically is equal to this thing where you have positive b a f of x dx. Okay, so you swap the limits and it removes the negative sign that you got. That's what I'm going to do over here. So I'm going to swap the limits. It's going to be 2, 1, and that negative 1 is going to go away. It's going to become positive according to the integral properties. So now I have this thing, which is very similar to what I have up there. All I got to do is I got to factorize this form over here. So this is basically u, it's negative u squared. So it's negative u squared. Then it's positive u, and it's 6, okay? It's positive 6. So I have to factorize this. So negative 1 times 6 is equal to negative 6. It's going to be 3 times negative 2, okay? And so this is going to be negative u squared positive 3u, negative 2u, positive 6. So we take the u's common over here, and that's going to be u, that's going to be 3 negative u in there. And then I have this other thing common, negative 2u plus 6. I can take the 2 common, and so I am going to be left with u negative u plus 3. I can actually go ahead and write that as 3 negative u. And so this thing is basically going to look something like 3 minus u, u plus 2, or 2 plus u, whatever you want to call it. So I am going to write over here 3 minus u and 2 plus u.